Okay, kiddos, here we go. We are going to start our first day of video notes for the class of Accelerated Math 7-8. We are starting a new module, and believe it or not, because you guys have looped and we are continuing our journey, we are now starting Module 8, and it is called Rational Numbers. We are changing our notebook a little bit this year because we need to keep track of these so that when we're doing video notes, we know where we're working. So I would like you to write the module number up at the top, so Module 8, Rational Numbers, just like I have, and we are going to begin with Lesson 1. Lesson 1 for today is going to be called Real Numbers. So I need everybody to write their title up on the top line, just like we always have, Real Numbers. And that's going to be the title heading for our notes for this entire lesson. Our goal for today is, everybody needs to be writing this down. Today we are going to learn the differences of real numbers. And you're going to have to bear with me getting used to this recording stuff. So, our goal for today. Today we are going to learn the differences of real numbers. Our question that hopefully everyone will feel comfortable answering at the end of the lesson today is, what are the differences of real numbers? I know that's kind of a silly question, but that's what we need to know. So again, the question for today's lesson is, what are the differences of real numbers? Okay, so hopefully after we go through this lesson, you'll be able to tell the differences. One thing that I want you to know is you do need to write everything that I do. We will be having tasks and stuff like that, and if you don't write the task, it might not make sense, but we'll work with that. So the first thing that we're going to talk about with the differences of real numbers is that real numbers are the numbers that mathematicians use. And in the middle school level, we focus primarily on real numbers. So the first thing that I want to do in our notes is, let's make a picture of numbers. And this is kind of a graphic organizer that I want you to see what the real numbers look like. So the first thing that I'm going to draw is, I'm going to draw a rather large rectangle. And this rectangle is actually a rectangle that you need to know goes on forever. But because my book is small and I have a lot to get written down today, I'm just going to put the arrows. These arrows all the way around my rectangle represent the fact that it's going on forever. Now this rectangle right here is going to represent the real numbers of our math world. Okay, so these are real numbers. And inside this area of real numbers are two categories. Okay, and the two categories are, we're going to draw a rectangle over here to represent one category, and we're going to draw another rectangle over here to represent the other category. Okay, so in this rectangle, we'll start over here first. I would like you to write the words rational numbers. Okay, and in this rectangle over here, I would like you to write irrational numbers. Okay, and so you have the two categories. The two categories are rational numbers and irrational numbers. We're going to talk at length about this side of our little picture, so I'm going to not talk about that for just a second, and let's focus on irrational numbers. Irrational numbers are exactly what the name says, irrational, because they are a little bit different. The best way to explain irrational numbers is the fact that they are numbers that cannot be written as a fraction. So the reason why you can't do that is because you never know where the ending value is. So for example, a lot of you have heard that pi is an irrational number, and the reason that pi is an irrational number is because it goes on forever and it never ends, and it never repeats, and it never stops, and there's not any specific pattern that it ever goes in. Pi goes on forever and ever and ever and ever. Mathematicians have actually been trying to disprove it forever, and they haven't been successful. So that's what makes it an irrational number, because it cannot be written as a fraction. So let's focus back on this side for just a minute, and the next thing that I want to put in our picture of numbers is you're going to go ahead and make a smaller rectangle. Notice I changed the colors to help you see it. So this next one is going to have integers. I could spell integers correctly, that would be helpful. Integers. Okay, so it's INTEGERS. Sorry about that, integers. Okay, and then I need you to draw another rectangle, and the next rectangle is going to go under integers, but it's going to be a little smaller. And in this rectangle, I would like you to write whole numbers. Okay, and then there's one more that you're going to write, and that next one that you're going to write is one more rectangle divided in here, and these are called natural numbers. Okay, so boys and girls, why in the world would I draw a picture that has all of these squished in here, and yet this one only has one in here? Okay, well, we're going to discover that in our discussion right now. So basically what you need to know is mathematicians use numbers all the time. The ones that we focus on in the middle school level are real numbers. Those real numbers are divided into two categories called rational numbers and irrational numbers. Our major focus in 7th and 8th grade math is rational numbers. We do learn about irrational numbers, but we don't work with them a lot in the 7th and 8th grade material. You work with irrational numbers a lot more once you get into algebra. But I wanted you to have a sense of what these two types of numbers are. So what we're going to do is we're going to go ahead and define all of these so that you can make a clear understanding of the difference of these different types of numbers. So the first thing that I would like to explain is, let's go ahead and get our definition of real numbers. So you're going to say the real numbers of our world belong in two categories. Those categories are rational and irrational numbers. So those are the two categories, just like in our picture up above. Okay? Rational and irrational. So these are real numbers. And again, we focus primarily on real numbers in the 7th and 8th grade curriculum. Okay, irrational numbers, just so that you have a definition, so that when you forget what this is all about, we can refer back to it, because remember, our composition book is supposed to be similar to a textbook, since we don't have one. So irrational numbers are numbers that cannot be written as a fraction. And what that means is there is no value that can be represented in the fractional form. And since there's no value represented, that's why they're called irrational numbers. Could you put pi, or 3.14, blah, 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 into a fraction? The answer is no, because we don't know what that blah, 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 blah is. So we can never find the denominator. So that's what makes it an irrational number. Okay? Everybody good? All right, turn the page. Again, you're going to write your title up at the top following our notes protocol. And just because I'm silly and I like to keep my pages similar, my title today is in this color. Real Numbers is the title. And then I need to remember to put my page number down at the bottom so that when we make our table of contents, our notes can stay in. I'm going to go ahead and put page 9 on there as well, just because I want to make sure that I don't forget. Okay, so the next one that we need to talk about, we talked about real numbers, we talked about irrational numbers. So now our next one that we're going to talk about is rational numbers. Okay, so we have rational numbers. Can you read that okay? Rational numbers. Rational numbers are numbers that can, keyword in this one is can, that can be written as a fraction. Okay? And then some examples of rational numbers. Pretty much anything on a number line that you can see on a number line or you can't see on a number line is considered a rational number. Okay? And the reason why it is a rational number if it's on a number line is because you could actually point on a number line to a specific spot, and that specific spot would represent a number. Some examples of this is you could have -1/2 on a number line. You could have 103 on a number line. You could have 7.25 on a number line. So basically, rational numbers are any numbers that can be written as a fraction. Okay? So those are rational numbers. Okay, moving on. We now are going to talk about integers. And integers are all the positive and negative whole numbers usually representing on a number line. And the thing that's the kicker about integers is that there are no fractions or decimals. So if it's a -2.5, then it's not an integer, okay? So the thing you have to know about integers is integers can only represent positive and negative whole numbers. The numbers have to be whole. They can't be parts, okay? So examples of integers are -20, +20, okay? 1 or -1. 0 is also considered an integer because it's a whole number, okay? So those are integers. All right, the next one that we're going to talk about is whole numbers. Do you see a pattern of our notes, guys? If you go back to that, got the wrong color, sorry. If you go back to that little picture that we did, the graphic organizer on the other page, you will notice that we're writing our definitions based off of that little diagram that we drew. So whole numbers are all the positive numbers without, this is really crucial, without fractions, decimals, or negatives. You cannot have any negatives if you are talking about whole numbers. Okay, so the keys to understanding whole numbers are they are positive numbers without fractions, decimals, or negatives. So examples of whole numbers are, I think you guys can come up with some very easily, but 1 or 0, 1, 2, 3, 108, 512. All of these represent whole numbers because they're all positive, and there are no fractional pieces and there are no decimal pieces. And so that's what you have to be aware of with the whole numbers. Okay? And the next one that we're going to discuss are natural numbers. And I think this is the last one in our diagram. So we have natural numbers. Okay? And natural numbers are all the positive numbers above 0. So 0 is not considered a natural number. Okay? Thing to remember again is without fractions, decimals, or negatives, these are also known as, or also called, counting numbers. So I have a question for you, because this makes me giggle and it makes me remember that we need to talk about this. They're also called counting numbers. When you are counting the candles on a cake and you point to one of the candles, do you ever say 0? Probably not, because if you're saying 0, then that means there are no candles there. So when you start counting something, you always count the number that you see. And when you start counting, we always start with 1, because 1 represents the item that you're touching. And so natural numbers are also known as counting numbers because you don't ever, if I was going to count these pens right here, okay, I wouldn't point to this pen and say 0. I would point to this pen and say 1, 2, 3, 4, 5, 6. So there are 6 pens right here. Those are counting numbers, okay? So we have that. Examples of natural numbers, also known as counting numbers, are, notice I'm not including the 0 this time, 1, 2, 3, 4, 5, because that's how we count, okay? So you should now know the differences between all of the real numbers that we've discussed. Okay, we have irrational, we have rational, we have integers, we have whole numbers, and we have natural numbers. Okay, and what I would like to do, because your question from this lesson was, what are the differences of real numbers? Hopefully, by just going through these definitions of these words, you should be able to answer our question for today, which was, what are the differences between real numbers, or differences of real numbers? I do have, just because you know me and I like to draw pictures to help kids be able to see and understand a little better, I do have one more picture that I would like to include, and so that picture is going to go right here. So the last thing that you're going to put on your notes for today is another picture, please. And what we're going to do is we are going to draw a number line. And remember, when we draw number lines, you have to have arrows on both ends so that we know that it goes on forever and it's continuous. Okay? And the reason we're drawing a number line is because we're trying to understand what the differences are between real numbers. And so if we draw a number line, the number line is a visual tool that can help us see the differences between the different types. So the first thing that I want you to look at is we have irrational numbers. Could I represent an irrational number on this number line? The answer is no, because there is no exact point on here that we could put it. So I would like you to make a dot clearly somewhere off the number line, so it's not even touching the number line in any way, and we're going to put an arrow from there, and you are going to write irrational, okay, and put irrational number, because that irrational number doesn't sit anywhere on the number line. So then the next one that we do have, however, is we could put a dot. Oh, wait, we need to number our number line. Silly. Okay, so I'm going to put 0 here. And then to my right would obviously be 1 because we're counting up by 1. So 1, 2, 3, 4, 5, 6, and 7. And then the converse of that are the negatives. So we're going to do -1, -2, -3, -4, -5, -6. Okay, so now we have our number line labeled. There we go. Nice job, Mrs. Nelson. Okay, now we can put a rational number somewhere on this number line. Remembering that the definition of a rational number is they are numbers that can be written as a fraction. So if they can be written as a fraction, they can also be a decimal because 7 and 25/100 is the same as 7.25, yes? So we could pick a number anywhere on this number line to represent it, and I am going to pick right here. If I picked right here, what would that number be? Well, we can talk about that in class tomorrow when you come. So this, you are going to draw an arrow up from it, and I would like you to write rational number, because this little orange dot represents a rational number on the number line. Okay? Now I'm going to pick up red. Why do you think I'm using red next? Because it correlates with my definition up above. So red is supposed to be an integer, and I am going to choose this number right here on my number line, draw a red dot on it with a red arrow, and I want you to write the word integer above it, because an integer is any positive or negative whole number. No fractions, no decimals. So you notice I put the dot exactly on the -1 because it can only be a positive or negative whole number. Okay? The next one that I want you to do is your whole numbers, remembering that a whole number has to be all the positives, and it does include the number 0. Okay? It cannot be fractions, and it cannot be decimals, and it cannot be negatives. So I am going to choose, of course, 0 to represent my whole number today. Is 0 the only whole number? No, but it's the one we're going to choose for our example. Okay, so that is a whole number. And then our last one that we are going to put on our number line for today is the natural number, remembering that natural numbers can also be represented as counting numbers. And so I'm going to choose the number 3, because when I have 3 items, I can count by 3. So this one is going to be a natural number. Now, the cool thing about this picture, because remember I said we were drawing a picture. So what you need to do on your picture is remember the rules of what they are. So natural numbers, do they start at 0? No, they start at 1. So I like to take a little arrow from 1 and draw it to follow the number line to the right, because this little blue arrow is including every number from 1 and above. Those are natural numbers. Whole numbers are all the whole numbers from 0 and up. So again, I'm making another line that's going to the right to represent all the whole numbers, remembering that it has to start at 0. And then integers are those glorious numbers that get to go both ways because integers encompass all positive and negative whole numbers. So we get to draw a long red arrow that spans the whole number line because integers are fantastic numbers that go on forever, whole values, positive and negative. So that's the last picture that we're going to add to this number line. And hopefully, by drawing this little example, you can now keep all the different types of numbers straight. Irrationals, not on a number line, because we can't represent them as a fraction. Rational numbers are all of these numbers that can be represented on this number line, fraction and or decimals, positive and negative. Integers can only be whole number values, positive and negatives. Whole numbers can only be the positive whole numbers, starting at 0, and natural numbers are all of the positive whole numbers starting at 1 and going up. Remember that you cannot have fractions, decimals, or negatives in natural numbers or in whole numbers. It's kind of confusing, but I think with more practice you'll get it. Okay, I hope that you guys understand our lesson for today. Oh, one more question. Let's review. Go back to our question of the lesson is, what are the differences of real numbers? You need to be able to answer